So let's talk about a sequence, how we can sort of like organize our thoughts about sequences and series. So let's talk about what a sequence is. A sequence, a definition, sequence. The definition is, a sequence is simply a list of numbers. A list of numbers. A list of numbers in order. I will say in order. Where you have the first number, first number. You have the second number. You have the third number, etc. A sequence has to be a group of numbers in a particular order, that is, maybe following some kind of pattern. A sequence of numbers, a list of numbers in order. And so we call this sequence, we'll call it a big S, big capital S, a sequence. And not equals, but sequence. And we write the sequence in a very particular way. We use subscripts. So we say the first term, the first piece of the sequence, we call that number A1. And then the next number is A2, A3, A4, etc. until you reach a general number A sub n, and then you keep going. So this is how we kind of write out a sequence using these A's. These A's represent like the number of the sort of location, right? The first location, the second location in the pattern. The sequence is made by this particular pattern, right? Each of these pieces, the first, second, third, this is what we call a term. And it is the number at a specific place, at a specific location. Specific location. So this is the first term, this is the second term, this is the third term, etc. First term, second term, third term, fourth term. This we call the nth term. Right? First term, second term, third term, etc. So this is the first term, the second term, third term, etc. Third term, fourth, fifth, etc. This would be the nth term. Nth term here. Nth term, we also have a special name for this. We also call this the general term. General term. This is like describing the pattern. This will give us the general formula for the sequence. When we use a general term, this is going to be the general formula, general formula for the sequence. It represents the formula, the equation that we're going to use to find this particular pattern. So the nth term is what we use for the general equation. So we have these terms at specific locations, right? The first, second, third term, etc. We have our nth term. And I want to clarify between two different types of patterns as well. Some sequences have a beginning and an end. So we have, let's say here, from numbers 1 to number 4. So we stop here. We call this particular group of numbers, like a particular set, we call that a finite sequence. Finite sequence. It is a limited number of terms in a sequence, A finite sequence is a particular group of numbers. So like from the first, second, third, and fourth, these 4 comprise a finite sequence. So sometimes you have a limited group of numbers. A limited number of terms in a sequence is a finite sequence. But if you go on forever, here we are, dot, 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 right? Keep going. Well, if you keep going forever, that would be an infinite sequence. So let me do that over here. Infinite sequence. Which is what S is, because it keeps going forever. Dot, 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 keeps going. An infinite sequence is a pattern with a starting number, starting number that never ends. Number that never ends. So we have these patterns of numbers, we have these sequences of numbers that we use to describe, and these terms we use to describe the locations of numbers in this pattern. So these are terms. We have a finite sequence or infinite sequence, and we have this general term that describes the pattern. It basically describes the equation, the formula that we use to create the sequence. So let me show you what I mean. We'll talk about these different kinds of sequences. What a sequence is. Sequence. It's 2 dots there, by the way, it's a definition. A sequence. It's a list of numbers in order, right? It has to be in order. You can't just mix them around. It's got to be a particular way, right? Because that particular order makes a particular pattern. It's like the Fibonacci sequence is in a particular order, right? 1, 1, then 2, then 3, then 5, in that order, following that pattern. So let me tell you how we break down a sequence is we give an equation for it. We describe the sequence using this general equation, and we can then use that equation to create a sequence. So let me show you what I mean. For example, let me say find the first 4 terms. Find the first 4 terms of the sequence. And I'm going to give you an equation, a general formula. A sub n is 2n minus 1. Here's my general formula. Here's a sequence. This is describing a pattern. This is a description of a pattern telling us a location, telling us a number, right? So I want to find the first 4 terms of this sequence, first 4 numbers in this pattern. And so the way this is going to work, first 4 terms, is I'm going to use my A numbers, right? I'm going to say, okay, well, I want A1, I want A2, A3, and A4. So if I want A number 1, if I want the first number in this pattern, the n, right, this n here, is the n in the location. This is my first number. It tells me what term number, what location I'm at. So I'm going to use the number 1 in the n here. A1 is 2 times 1 minus 1. So that's my pattern. I'm using my first term, so I plug in the 1. So 2 times 1 is 2. 2 minus 1 is 1. And then I do the same for the second one. A sub 2, my second term. So since it's my second term, my n, this n here, is a 2 now. So I'm using the location number. I'm using the location number as the number that changes my pattern, involved in my pattern. 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. And the same thing for A sub 3. Use my pattern here. 2 times, now I'm going to use number 3. It's my third number in the pattern. 2 times 3 is 6. 6 minus 1 is 5. And A sub 4. Same thing. 2 times a 4 minus 1 gives me 7. So I've got 1, 3, 5, and 7. That is my first 4 terms of this pattern. What do you notice, everybody? What kind of pattern is this? What did we just create? What's interesting about these groups of numbers? If you keep going, it's going to keep going the same thing, right? What do you notice? What kind of numbers are these? Yeah, Destiny, these are the odd numbers. This equation creates the pattern of odd numbers. This is the odd number sequence equation. Odd numbers. This pattern creates, this equation creates the pattern of odd numbers. Multiply whatever position you're at by 2, and then minus 1 to get the odd numbers. If we didn't do the minus 1, we'd get the even numbers. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2, 4, 6, 8. If we didn't do the minus 1, we'd get all the even numbers. Very interesting, very interesting. So we can have different kinds of patterns. We can see different patterns. We can use equations to create a pattern. And the more complex the equation becomes, the more interesting the pattern becomes. So let me see if we can describe one of the patterns we did before. Or, let me do Let me do another one. No, let's go up here. Hold on, let me look at this. So, what patterns do we do here? We did our even numbers. What about this pattern? 1, 2, 4, 7, 11, 16, etc. What if we tried to make a pattern now? Let me let me do this here. What if we tried to write an equation for a pattern? Oh, goodness gracious, hold on. Write an equation for the pattern. So what if I had the numbers, let's do an easy one. 2, 4, 8, 16, 32, etc. All right, here's another pattern. So you know how patterns work, right? We're looking for this a sub n equation. We're looking for this main equation here. Let's look at this equation. What is this pattern doing here? What is happening in this pattern of numbers? 2, 4, 6, 8, 16. What are we doing here? What pattern is that? Anybody know? What do we see? What am I doing to each number? How is this changing? What's the pattern here? Yes, Edward, very good. Doubling the numbers. Yeah, so when you say doubling, what mathematical operation am I doing? Am I adding something? Am I dividing? What am I doing? Multiply by 2. Yes, thank you. Doubling means multiply by 2. So we are timesing by 2 every time, right? Doubling it up, multiplying by 2. So how can we take this pattern of numbers and create an equation describing the pattern? I want to say a sub n equals, what is the equation I could write? How can I do this? How can I write an equation here? What's the way that I could write an equation that would get this pattern? Something about multiplying by 2. Something about multiplying by 2. What's a way I could do this? Well, there's a couple ways we could create this pattern here. What we can say is take the previous number and multiply it by 2 to get the next number, right? So how can I write an equation that says take the last number, right? The easiest way to do this is say take the number that I'm at, take the last number, multiply it by 2. Right? So I want to do something times 2. How can I describe the previous number? The previous number. I want something here that says I want to take the last number and times it by 2. Well, if I'm on a sub n, right? If I'm on the fourth number, for example, if I'm on the fourth number, well, the previous number was a sub 3, right? If a sub 4 is my current number, the one before it is 1 less, a sub 3. right? If I'm on my fourth number, my previous number was a sub 3. So to describe the previous number in sequences, in patterns, we can say a sub n minus 1. That is a way to describe the previous number. If I'm on the 10th number, well, I take 10 minus 1 is 9. I take my previous number and multiply it by 2. If I want the 10th number, I take the 9th number and multiply it by 2. If I want the 7th number, I take the 6th number. N minus 1 is 7, 7 minus 1 is 6. So this term here, this special piece here, we have another special term here we call a minus 1. This is the previous number. And this is a way we can describe this pattern. And we call this method, since we use this special previous number, we call this a recursive formula. Using the previous number, previous, oh goodness gracious. Using the previous number, is called a recursive formula. Recursive formula. Sometimes that's the easiest way to describe a pattern. Saying, well, take the last number and do something to it. Take the last number, add 2. Take the last number, multiply by 4. Take the last number and divide it by 2. Whatever you're doing, right, that's a really easy way sometimes to describe a pattern using this recursive formula. But it's not the only way. And in fact, it's not the most useful way. Right? Advantage of the recursive formula is that it's easy. Easy to write the equation. It's easy to describe a recursive formula. We'll take the last number and do something to it to get the next one. Right? Like for even numbers, take the last number, add by 2. Take the last number, add by maybe n, right? So it's easy to write the formula. The problem is, what if I want the 100th number? What's the 100th number in this pattern? Well, to get the 100th number, I need the 99th. Okay, well now to get the 99th number, I need the 98th number. And I got to go all the way back to the very beginning and go all the way back all the way up to get the number I want. So it's not easy to get a particular number. Not easy. Not easy to find a particular term. You need all the previous numbers. Particular term. You need all previous answers. Previous. You would need all the previous numbers to get the next one. So I can't just like find any number I want. For recursive formulas, they're easy to write, but they're not like not great for looking at like if I want the 100th number. It's not easy to find a particular term. You need all the other numbers to get the next one. So I would need to go through the whole answers to find all 99 before I can get to the 100th answer. 100th answer. Which is not great. Not great. So there's another way we can do it. And it's the kind of formula we had last time. We can use another kind of equation called an explicit formula. Explicit, hold on. explicit formula. And these are a little trickier to figure out. But they give us all the numbers we need. So what kind of equation, if I want to do, if I want to think of like a y equals equation, like a formula for this equation. Remember, this is my first term, my second term. These are the n's, right? 2, 3, 4, and 5. These are my n values, my terms, right? My first term, second term, third term, fourth term, fifth term. How can I use these numbers? What can I do with these numbers in an equation to get this value here? Something with a 1 to make a 2. Something with a 2 to make a 4. Involving 2's, it's hard to figure out. How many 2's are in 2, everybody? How many 2's? How many 2's do I multiply together? Well, to get 2, I just have 1 2. How many 2's do I multiply together to get 4? Oh, that's 2 2's. How many 2's make an 8? 3 2's. How many 2's make a 16? 4 2's. So this n value, this number up here, is telling me how many 2's I multiply together. 5 2's multiplied together make 32. So the way I can write this equation, I can say it could be 2 to the power of n. 2 to the power of n. An explicit formula for figuring out this equation. Right? So it uses the n value to make a formula to calculate the term. Advantage is it finds, you can find easy to find any term. Right? If I want the 100th term, this makes it easy. I just put 100 in my n, right? I use the n value to make a formula, the nth term. I use 100 here, I plug in 100, bam, I get the equation. I get the number. What is the 72nd term? Well, I just plug in 72 and I get my answer. That is the location. That is the 72nd term. I use the n in the formula. So it's easy to find any number, but it's like hard. It's not easy to find the equation, to find the formula. So these two different kinds of equations, we have a recursive formula, we have an explicit formula, two different styles that we can use to calculate our values here. A recursive equation and an explicit equation. So given a certain pattern, you can find out the kind of, you can come up with an equation to describe the term. So recursive formulas are pretty easy. Explicit formulas a little more challenging. Questions about this? What questions do you have? No questions so far? All right, let's come up with, let me show you a couple equations, a couple patterns. Let's see if we can come up with the equations for them. I'm going to show you a couple patterns. We'll see if we can come up with some equations describing that pattern. Both a recursive and maybe an explicit if we can. Okay, recursive and explicit if we can. Let's go with this one here. Find an equation. Find an equation of the pattern, or for the pattern. For the pattern. Let's do let's see. What's a good one? 1, 5, 9, 13, on and on like that. What's an equation we can use for this pattern? Let's come up with a formula. 1, 5, 9, 13. Keep going here. 17, on and on and on. What am I doing in this pattern? Someone tell me what's happening in the pattern. Adding 4. Very good. Adding 4 each time. Adding 4, right? Plus 4 here, plus 4 here. Easy. So what equation can I write? Either an explicit formula or a recursive formula to describe this equation, to describe this pattern. What equation can I write? A sub n equals, what's an easy description of this pattern? A sub n equals what? I'm adding 4 each time. If I'm adding 4 every time, it's really easy to write a recursive formula. I can say, well, this is going to be A, take the previous number, and add 4. There's a pattern. That's an equation. It's a recursive formula because I use the previous number. I say take the previous number, add 4. It's always n minus 1 because I always want the previous one. I want to go 1 backwards. Minus 1. I want to go 1 step back to the previous number. It's always minus 1 because I want to go only 1 step back. So take the previous number, add 4 to it. To get my 9, take the previous number, take the 5, add 4. Right? So that's an easy way to write the formula. The explicit equation of this is a little more challenging. Anybody think they want to know this one? Let's see. It's going to be 1 plus, I'm adding 4. How many times do I add 4? N minus 1 times. Ooh, this is a weird formula. I have my starting number. I add 4. How many times have I added 4? Well, I add 4. In the second number, I add 4 once. In the next number, I add 4 2 times. The fourth number, I add 4 3 times. So n minus 1 is a little tricky to find this explicit formula. We'll talk about how to do this more precisely later, right? This is an explicit formula. All right, one more, real quick, one more. Find a pattern. Find an equation. I'm going to do this one here. 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, dot, dot, dot. Find an equation for this. What's the pattern? What am I doing every time? What's changing here? Am I adding something every time? Not really. Am I dividing? No. What's changing? Well, the thing that's changing is the bottom number is increasing by 1. Increasing the bottom number. In fact, this is the first term is the 1, the second term is the 2, the third term is the 3. It's the position number on the bottom. I'm not really adding anything. I'm not like, it's just I'm putting the n down here. I'm going down, right? But it's a weird pattern. So easy pattern I can do is I can say, well, the answer is it's a 1 on the top, and whatever number sequence I'm in, that's the number on the bottom. Right? This is my n numbers. N is 1, 2, 3, 4. My n number, the term number, the location number, is the number on the bottom of this pattern. Is the number on the bottom. So my pattern is just, well, it's 1 over whatever number I'm at. The 90th term is 1 over 90. Whoopsies. So that's explicit. Explicit, because I use the n. A recursive formula? Recursive? I don't really think there is one. If you can think of one, like, because I'm not really doing anything to the numbers. I don't think there is a recursive formula for this pattern. If I'm wrong, let me know. But I think that I don't think it works that way. I can't just add 1 to the bottom number. It's gotta. Anyway, lots of patterns. We'll get into this. We are out of time, however. Let me show you what your homework is. It's a little discovery of some patterns, some sequences. Let me get into that and then let you go.